All right, so you guys did some simple Lewis structures last week. I'll go through a few more examples with the book slideshow, but they really don't show you all they need to here, and they kind of show it in a bad way. So just as a reminder, notice we made something like the water molecule. You got an oxygen and two hydrogens. Now they're kind of just having you put oxygen, 6 electrons, and pair up hydrogens with them, which is fine. But for more complex molecules, it's usually better just to grab all the electrons and then sort them out at the end. So notice oxygen comes in with 6 valence electrons. How do you know that? Because it's S2P4. 2 plus 4 is 6. Advanced math again, right? And then, so you got 6 electrons, and then each hydrogen brings 1. That's 2 more. 6 plus 2 is 8. And that's an easy one, obviously, because you make your bonds to the hydrogens, and that uses 2 4 electrons, and then 6 8 gives you the lone pairs. Oxygen has 8 around it, each hydrogen has 2 around it, and it worked out well. Another quick example they show is the methane molecule. Notice again they show carbon with the electrons split up like I told you about, and then move on the hydrogens to it. Once again, it's better probably to add up all 8 electrons and then distribute the bonds, but whatever. Notice that they give you very, very simple ones to deal with. Now, notice we've been making single bonds, which means one bond between each element. Coming up later today, assuming I get time for it, we'll look at how do you form a double bond or a triple bond. I don't want to get too much into these because the way they're drawing these configurations isn't really entirely correct anyway. HCl is another easy one. There's 7 for chlorine. S2P5 is 7, plus 1 more for hydrogen, that's 8 again. So they're keeping these really simple, aren't they? Let me leave this behind and show you a little bit more complex one, something that I think showed up on your worksheet. If not, it was something similar. Let's do nitrogen trifluoride. Now, we know it's going to be nitrogen surrounded by 3 fluorines. There, right? Rather than, again, try to count out everybody's electrons individually, let's group them all together. Nitrogen came in with, well, S2P3, so 2 plus 3 is 5 electrons. Fluorine has 7. S2P5, 2 plus 5 is 7. And of course, since there's 3 fluorines, 7 times 3 is 21. So you have total electrons here. 7 plus 7 plus 7 for the fluorines gives you 21, plus 5 more for the nitrogen, that gives you 26. By the way, notice it's a neutral molecule, so that's all the electrons. If this had been a negative charge on this, well, remember, electrons are negative, so I would have to add 1 more electron. If it's a 2 negative, I would add 2 electrons. If it's positive, I would remove electrons, and so on. But for now, we'll stick with neutral molecules. Now, we have 26 electrons to work with. So what do we do with them? Let's start making bonds. There's a bond between nitrogen and fluorine, and I've used 2 electrons. Remember, a dash is a pair of electrons, or a bond, right? So I've used 2, 4, 6 electrons. I've made all my bonds. Everybody's bonded together. The molecules stick together. And I've used 6 of my 26 electrons. So now what? The rest of the electrons go to make lone pairs. Now, it's usually best to start with the atoms hanging off the central one. Don't start with the nitrogen in the middle, no matter what the book tells you. Start with the stuff hanging off of it. Now, notice the book's examples, they were real careful to always make these hydrogens so you didn't have to worry about that, because hydrogen only needs the 2 in the bond and that's it. But I gave you fluorines, and so, well, they need 8 just like everyone else. So we'll start with this fluorine. Could start with anyone, really. It already has 2 from the bond. There's 4, 6, 8. It now has 8 electrons. Now, how many did I use total? I should keep a running total. 2, 4, 6 for the bonds, 8, 10, 12. All right, let's do the bottom fluorine. 14, 16, 18. Notice it has 8 electrons around it now. Count them up. The bond is 2, don't forget. And I've used 18 electrons. Now we'll deal with the next fluorine. 20, 22, 24. Okay, it has 8 electrons, and I've used 24, right? 2, 4, 6, 8. Okay, so now the only one that doesn't have 8 yet is nitrogen. It only has 2, 4, 6. Well, how many electrons did I use? Scroll back if you need to. I used 24 electrons. I have 2 more left. There's the last 2, and that's just enough to give nitrogen its full valence shell, 2, 4, 6, 8. So I've used all 26 electrons. Everybody got a full shell out of the deal. Everyone got their 8 electrons. Remember, if one of these had been a hydrogen, it would only have needed the 2 in the bond. But when they're not hydrogen, they need to be surrounded by 8. So we got a full shell for everyone. We've used all our electrons. Everything worked out perfectly. You can't ask for better than that, right? Now, let's look at, I won't go back into the slideshow yet, but they start dealing with this. If you run short, let's look at the O2 molecule. Normal diatomic oxygen that you're breathing right now, assuming you're all on Earth. So obviously the Lewis structure is O bonded to O. How many electrons? Well, look up oxygen on your periodic table. S2P4 means 6 electrons for each oxygen. So 6 for this one, 6 for that one gives you 12 electrons to work with. Okay, so let's do the same thing we did before. Step 1, make a bond. Well, I've used up 2 electrons, right? Now what? Let's start giving the atoms their full shell. So I use 2, 4, 6, 8. I've used 8 electrons, and that oxygen now has a full shell. Okay, so 10, 12, wouldn't matter which side I put them on. I like keeping it symmetric, but I could have put them on the side it wouldn't have mattered. I've used all 12 electrons, but notice this oxygen on the right is coming up short. It has 2, 4, 6 electrons around itself, and remember they all want 8. So I would love to be able to put 2 more electrons right here to fill it out, but I already used all 12 electrons. Let's double count. 2, 4, 6, 8, 10, 12. So I did make a mistake. I used all my electrons up, and I came up short electrons. So now what? Does the molecule just not exist? Well, you're breathing it right now, so it exists. So what do? Well, notice by sharing these 2 electrons, the left-hand oxygen counts them, and the right-hand oxygen counts them. So it's kind of like we're getting free electrons out of the deal. And not really, but they share them, and so it counts as more. So since we come up short electrons, let's share more of them. If you take away, say, these 2 electrons, I'll just erase them. I don't have any, well, I do, and I want to change over to the eraser. So erase those 2 electrons and instead shift them into the middle and make a bond out of them. Now, I didn't get rid of any electrons, I just shifted them. They used to be a lone pair over here. Now they're a shared pair forming a bond. Let's count to be sure. 2, 4, that bond is 2, that bond is another 2, that's 4, 6, 8, 10, 12 electrons. So I still got my 12 electrons. But now look, the left-hand oxygen has 2, 4, 6, 8 around it. So it didn't get hurt by anything. It used to have 8, it still has 8. The right-hand oxygen now has 2, 4, 6, 8 around it. So now everybody gets 8. We kind of cheat it. We counted these electrons in the middle twice because both oxygens get to use them. That's the value of sharing. So often when you're making your Lewis structures, like in the previous example and the ones we did last week, you have just enough electrons, you give everybody their electrons, and everything works out. Sometimes you come up short. And when that happens, what you got to do is make a double bond somewhere. In this case, it was pretty easy where to make the double bond because there's only one place to put the bond. Sometimes you have to make decisions on where to put that double bond. But that's really all there is to it. And then you'll have enough, hopefully, to go around. If not, tomorrow we'll look at triple bonds. Let's look at one slightly more complicated example. Let's clear this. And let's do the nitrate polyatomic ion. We all memorized our polyatomic ions, right? Nitrate is NO3 with a negative charge. So the structure is going to be nitrogen surrounded by oxygens. How many electrons do I have to work with? Well, nitrogen comes in with 5. Again, look on your periodic table to check that. Make sure you can do this. If not, message me, because it's important that you can count your valence electrons. Each oxygen comes in with 6. So 6 times 3 is 18. Now, notice in this case, it's not neutral. It's got a negative charge on it, right here. A negative charge gives you 1 more electron. If it was a 2 negative, that would give us 2 more electrons. So now we add them up. Okay, 18 plus 5 is what, 23? Plus 1 more is 24. I hope I counted that right. So 24 electrons. You have 24 electrons to work with. So what do? Start off making your bonds. 2, 4, 6 electrons used up. Now the rest will do lone pairs, starting with the outside, working your way in. So on the oxygen, we've used 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so I've used all my electrons, all 24 electrons. All the oxygens are good. They're happy. But poor nitrogen has 2, 4, 6. It's missing electrons up here. So what do? Well, just like we did before, let's make a double bond. Which oxygen do we take the electrons from? Doesn't matter. They're all oxygens. They're all the same. Now, be aware that maybe tomorrow, maybe the next day, I'm not sure when we'll get to it, we're going to look at how it might matter. And then we'll look at what happens if you make different choices. But for right now, for simple Lewis structures, it doesn't matter which one. Let's pick this guy on the right since I made its electrons ugly anyway. We'll erase 2 of its electrons, make it a double bond. And again, notice the oxygen didn't get hurt by that because it still has 2, 4, 6, 8 electrons. But now nitrogen gets to count these 2, 4, 6, 8 electrons. It's got a full shell too now. So by forming a double bond, we gave everyone their full shell. And that's it for Lewis structures for today. Again, I want you to practice this. I'm going to give you more Lewis structures to do. Some of them will involve just making single bonds like before. Some of them will involve making double bonds. So you'll have to decide, what you're going to do. So we'll do some practice today, and then tomorrow we'll move on and look at some triple bonds and how they might work. And that's it for today.